Welcome everybody. Today we're going to be talking about properties of tangents when they relate to circles. So again, remember tangent is a point that touches a circle at exactly and only at one space. So a theorem that we're going to start off with today. This is that if a line is tangent to a circle, it's perpendicular to the radius. So to be clear, we draw a circle. There is a point right here of tangency that goes perfectly down. And then what we're saying is, okay, if we look at the center of the circle, that means that if this is in fact a tangent, then there has to be a 90-degree angle there in terms of where the radius meets the tangent line. So just to label all of the pieces here. And then a second way to put this theorem is that if a line is perpendicular to a radius, it's kind of like the converse, then the line is tangent. So it goes both ways. So this is just basically telling us that, all right, so if we draw a tangent line and it's perpendicular to the radius, then we know that it is in fact a tangent line, and vice versa. If there happens to be a line and then we measure that it's perpendicular, we can prove that it's tangent. So both of those ways work. And how this is going to apply to our questions today is they're going to give us a circle and a tangent line somewhere, maybe up top this time. It only crosses at one point here. And again, give us the radius and a triangle. And they're going to ask us, is it tangent? And we're basically trying to prove, is this a right triangle in order to do that? So we want to see, is the line that goes from C to E tangent to, we'll say, circle B. And the way that we prove this is we need to determine, is this a right angle? If it is, it's tangent. If it's not, then it's not tangent. So they're going to give us some information, and we're going to have to solve based off that information. So let's say in the question they tell us, okay, this measure is 11, this measure is 45, and this measure is 43. So with those three measures, we have to prove, is that or is that not 90 degrees? Well, we have a lot of tools at our disposal. We can use SOHCAHTOA, we can use our triangle properties, but the best thing to use when we have three sides is a squared plus b squared equals c squared. We can go to the Pythagorean theorem. So again, plug in the side that relates to each part. So 11 squared plus 43 squared equals our longest side, our hypotenuse, of 45. And we can go through and solve this. So 121 plus 43 squared is 1849 equals 45 squared, which is 2025. So we can put our like terms together. 1849 plus 121 equals 1970. And what we're going to see is this is not a true statement. So because of that, the Pythagorean theorem doesn't work. And because of that, we can say that there is not a 90-degree angle, so it's not tangent. It might look tangent, it might look to your eyes to be close, but unless we can, prove it using either our trig functions or Pythagorean theorem, it's not going to be the case. So this can be a little bit confusing. I'm going to do one more example here to show us another way to calculate this. So again, we have a circle. And then we have our line of intersection. Maybe it's up here. And then we'll call this A, call this B, and we'll call this C. And they want to know, so that's a radius from A to B. is this 90 degrees? Is this line tangent? And they give us this side is 4, this side is 5, and this side is 3. So again, we can identify our a squared, b squared, and c squared. So 3 squared plus 4 squared equals 5 squared. And 9 plus 16 equals 25. Well, let's see. Is that true? 25 does equal 25. So if it's true, we can say yes, it is tangent. So the first few questions you're going to see here are going to be very similar to this. You're going to be given some lengths, and you're going to have to determine is it or is it not tangent by proving whether or not it's a right triangle.